Welcome back to another YouTube video. Today we are going over the advanced math units inside of Khan Academy's SAT math prep course and all three foundations, medium, and advanced difficulty levels. You thought the last video was long. This one is going to be 39 questions. So we have a lot to get to. Let's go ahead and get started. You can see up in that top right tab, some of these we might have to use a graphing calculator on, but I'll explain exactly what we need to do with those ones anyway. Let's get started with this video. Make sure to subscribe if you haven't already. Leave any comments down below if you thought that this video was helpful. So with this first one, in order to solve this, we need to isolate our x. Okay, so our first step, that negative 81 is multiplying with our x squared, so we need to divide both sides by negative 81. That leaves x squared equals 11 over 81. And now we can solve for x by square rooting both sides. Whenever we square root a variable, we take both the positive and negative solutions. So that means that our answer is going to be positive or negative square root of 11 over square root of 81. Square root of 81 is 9. So then our answer is positive or negative square root of 11 over 9. So that means that C is our correct answer. We have to include those negative solutions. All right, on to our next question here. We have this expression and we need to rearrange it or isolate the C variable. How we isolate the C variable is that we need to move over that negative 5 first by plussing 5 on both sides. Now we have 3C equals D plus 5. And now to further isolate, there's a 3 multiplying with our C. In order to get rid of that, we divide both sides by 3. So that we have C equals D plus 5 over 3. So that means this is our answer. That matches answer choice B. On to this next one, we need to factor this expression. To factor this expression, we need to see what are some like terms. We may notice that each term here it shares in common a y variable, which means to factor it, we need to factor out or divide each term by y. When we divide each term by y, we are left with y on the outside, parentheses y plus 4x plus 3. And then this is what's going to be equivalent, matches with answer choice A. Just so we know, we can't factor out a 4. That 4 would have to be constant for each of our terms. The only factor that is constant in each of our terms is y. So that's the only thing that we can factor out. Now with this, we are going to be simplifying this. Properties of exponent style. So when we are dividing, remember, when we divide, our exponents subtract with our like terms. A to the 8th is like with a to the 2nd. So to simplify that, we would do a to the 8th minus 2, which would just be a to the 6th on our numerator. Now to do our b's, we would do negative 2 minus 10, which is b to the negative 12 on our numerator, which then, to get rid of that negative exponent, we move that term to the denominator, which means we are left with a to the 6th over b to the 12th. This is our correct answer here, which matches answer choice D. On to this next one. Biologist stocked a lake with a new species of fish. How many fish did the biologist initially add to the lake? This is an exponential relationship in the form of a, parentheses, bx. In this format, our a is our y-intercept. So we need to remember, when t equals 0, p of t, well, p of 0 equals 400, because 1.5 to the power of 0 is 1. 400 times 1 is 400. So that means that there were 400 fish initially in the lake. So the following is equal to this expression. We are just going to multiply out this 2x squared to each term. 2x squared times x is 2x cubed. 2x squared times negative 2 is negative 4x squared. So then we are looking for this exact expression. Answer choice D is correct. Alright, on to this one. We have two fractions here with the same denominators. So when our denominators are the same, we can just combine our numerators, which means that we are going to be doing 7m minus 2m. We can't combine the 2m with 5m squared, so our answer is 5m squared plus 5m, because 7m minus 2m is 5m, over 2m minus 9. We just need to think of just fractions when we have the same to subtract, we need the same denominators, and then our denominator stays the same, and our tops are going to actually subtract with each other. Remember, we can only combine like terms. So answer choice B is correct here. On to this next one. If the square root of x equals 6, what is the value of x? To isolate our x, to get rid of a square root, we need to square. So we square both sides. 6 squared is 36. So x equals 36, and we can just see square root of 36 is indeed 6. So that checks out answer for us. This next question, which of the following statements is true? We can see here that as x increases, y increases at an increasing rate. So that means that as we move to the right, our y is going to move up at a faster rate, which is exactly what's happening here. As we continue to move, our graph is going to get steeper and steeper and steeper, so that means that we are increasing at an increasing rate. Answer choice A is correct. For answer choice B, this shows that if we were increasing but then slowly asymptoting out, B is incorrect. C would be if we're decreasing at an increasing rate, so that means that we are decreasing very rapidly, and then D would just be, once again, asymptoting. So answer choice A is the only one that's valid here. If h of x equals this, what is h of 3? We need to understand that h of 3, the 3 is taking the place of the x. So that means any place where there's x in our expression, we're going to substitute that out for 3. So instead of x squared, it's 3 squared. 3 squared is 9. 9 minus 1 is 8. So we're left with 1 over 8 is our answer, or answer choice A. This next question, the system of equations is shown where a and b are both positive constants. What is the value of a? So right here, I would just recommend substituting both of these into Desmos, and then we can see our actual solutions. So let's go ahead and do that. Y equals x squared minus 2, and then y equals 7, I believe. Let's just double check that. Yep, so now we can just take a look. Our two solutions here where they intersect with each other is negative 3, 7, positive 3, 7. We can see clearly here that a equals 3. So that means answer choice B is correct. Alright, with this question, x minus 3 is a factor. What is the value when x equals 3? This, we don't even have to worry about this expression. We can use something, the definition of a factor. If x minus 3 is a factor, that means when we substitute in 3 for x, which is what we explained f of parentheses 3 is equal to, then we just get 3 minus 3, which is 0. That means the whole function is going to be 0. Once again, x minus 3 is a factor, so that means that 3 is a 0. So that when we substitute in x for 3, we get 0. It's an x-intercept of our graph. If we wanted to double check this, we could put this whole expression into our graphing calculator and then substitute in x for 3. We would get the same answer. It is 0. Okay, with this question here, we have a quadratic function, and with this formula we can see that it is in factored format. A factor, well, which is x minus 4, gives us the x-intercept, which is, of course, of this graph, 4. This is the constant or coefficient that is being conveyed here, so that means 4. It's just an x-intercept. That is what they give us here. Alright, that is all for our foundational difficulty level. Let's move on to the medium. Okay, on to our medium difficulty level. We have two functions, and we're trying to find the composite function. So how we do these, we take a look at our inside first. So our inside is saying g of negative 1, meaning that we're going to take function g and substitute in negative 1 for x. So function g when x equals negative 1 is going to be negative 5 plus 8. Negative 5 plus 8 is 3. So that means we have f parentheses 3 left. So in our f of x, we're going to substitute in 3 for x. When we substitute that, we have 1 over 3 minus 1, which is just 1 over 2. So that means that our answer is 1 over 2. Alright, this, we are going to use our power of a power exponent rule here. So power of a power, we multiply. So doing n to the 6th times 5, which is n to the 30th. And then we have k to the 14th to the 5th. Power of a power, we multiply. So 14 times 5 is going to be k to the 70th. So now we have n to the 30th, k to the 70th. Now given here, we can go ahead and simplify this further. So as we can see here that our answer choices, This one factors out at 2. Let's take a look and try that. If we factored out an exponent of 2, we do the opposite of power. We would divide. So we would do n divided by 2, which is n to the 15th, k to the 30th. So n to the 30th, k to the 70th, or 35th, my bad, is just the same as n to the 15th, k to the 35th to the power of 2. These are all equivalent to each other, so that means answer choice C is correct. A would get n to the 6th, k to the 15th, that doesn't match. B would get n to the 30th, k to the 14th, which doesn't match. And then D would get n to the 25th, k to the 70th, which once again doesn't match. C is the only valid answer. Alright, how many distinct real solutions does the given equation have? We can just type it in to our Desmos as x squared plus 1 equals 0. X squared plus 1 equals 0. And we can see here that indeed there are no distinct real solutions here. There are no real numbers that makes this equation equal. So that means there are 0 distinct real solutions. Okay, this equation, once again, we have an expression and we need to isolate it in terms of n, so we need to get the n by itself. First step in doing that is subtract 125 over m from both sides. Now we have L minus 125 over m equals 50n to get the n by itself. Now we just divide everything by 50. So we have L over 50 minus 125 over 50m equals n, and this matches answer choice A. We could write them under 2 denominators or just under 1. Both are a correct format. So that means, so we may notice that this is not shown as one of our answer choices. Instead, they simplify this 125 over 50. So, and this is not a 1, this is an L. So now we need to simplify this. We can divide both the numerator and the denominator by 25. We are left with minus 5 over 2m. So now we have L over 50 minus 5 over 2m equals n. This is the simplest format, which still expresses that. And we can see that this matches answer choice C. First, with this one, we just have to isolate and solve for the variable m. How we're going to do that, so we're first going to add 6 square root of 2 on both sides, 4 square root of 2 plus 6 square root of 2. We can just add the fronts together. That's 10 square root of 2. Now now we can move over this 2 square root of m on both sides. 7 square root of m minus 2 square root of m is 5 square root of m. So we are left with 10 square root of 2 equals 5 square root of m. We can divide both sides by 5. We are left with square root of m equals 2 square root of 2. And now to get the m by itself, we can just square both sides. So that means that we are squaring this entire thing right here. So that means we are left with 4 times 2 equals m. So m equals 8. That means that m equals 8 is our answer and is what makes this equation correct. On to our next question here. Which of the following is the graph of the system shown? All we need to do here is to simplify both of these, which is pretty much, we need to get this linear equation into y equals mx plus b format. We can do that by subtracting 2x from both sides and then switching around the equation, which makes it equal to this right here, y equals negative 2x plus 3. We can check which graphs have that. So A does indeed have y equals negative 2x plus 3. B has y equals positive 2x. And then D has positive 2x. So we can eliminate answer choices B and D. So now we just are looking at A and C. And then we can look at our quadratic function. Since this first term is negative, that means this parabola opens downwards. We can see that the only answer choice where we both have our linear equation correct and a parabola opening downwards is answer choice A. So that means answer choice A is a graph of the system of equations shown. Here we need to just simplify, combining like terms. Multiplying out, combining like terms is all we have to do. 2 times 3r is 6r, 2 times 7 is 14. And this, we need to distribute this negative sign as well. Pretend that is negative 1. Now we have minus 2 minus r. Now we combine like terms. 14 minus 2 is 12. 6r minus r is 5r. So we're left with 5r plus 12, which matches with answer choice C. All right, next question. Which of the following of the characteristics is displayed as a constant? This is, once again, a factored format of parabolas. The constant given in this equation is an x-intercept. So that means that A is correct. We're given the x-intercepts of the graph. All right, here, which of the following is equivalent? We're just going to factor the greatest common factor. Factor this entire expression, actually. So first, we can factor out the GCF of 2 from each term. So that equals 2, parentheses, x squared minus 25. And now to further factor this, we can use a little trick called difference of squares, where a squared minus b squared equals parentheses a plus b, parentheses a minus b. So we can factor x squared minus 25 as just 2 parentheses x plus 5 parentheses x minus 5. So that means that this is the equivalent expression, and answer choice B is the correct answer. Okay, on to this question. The population of Japan, where negative values of t represent years before January 1st and positive values of t represent years after January 1st, 2000, is projected as this. According to this projection, during which year does Japan reach its maximum population? Do not stress too much with this question. Replace the p with a y, replace the t with an x, and then just put it into Desmos. So this looks like this: 128 minus 0.012 parentheses x minus 9.71 squared. Alright, and now we can see what is the x value where we reach the maximum amount of years. During which year does Japan reach its maximum population? So that x value is 9.71, and that year would be year 9 after January 1st, so that is 2009 is when Japan reaches its maximum population. With this question, we need to understand that this division bar can just turn into the horizontal division sign, and then we can change flip to find our answer. So 2x minus 6 over y divided by x minus 3 parentheses y plus 1. To solve this, we can change flip. So we keep the first fraction the same, 2x minus 6 over y. We flip we change the division sign to a multiplication sign, and then we flip the last fraction into its reciprocal, y plus 1 over x minus 3. Now we can multiply horizontally, so we are left with 2x minus 6 parentheses y plus 1 over y parentheses x minus 3. And now we're going to have to simplify this. So right off the bat, we can factor 2x minus 6 as parentheses 2. Well, we can factor 2 out, so that's just 2x minus 3, which is then going to cancel with the x minus 3 on our denominator. So that means we would be left with 2 parentheses y plus 1 over y, and that means that answer choice A is the correct answer here. Okay, if the function has two distinct zeros, which of the following represents the complete graph of f in the coordinate plane? So two distinct zeros means two x-intercepts here. A just has 1, and C has 3, and then D has 3. That means answer choice B right here. We just have two distinct. We have an x-intercept here and an x-intercept here. So that means it is the answer for this question. Okay, we have this function, has a y-intercept of 0, k. What is the value of k? So we're going to substitute in 0 for x and find the corresponding y value. When x equals 0, 2 to the power of 0 is 1. 3 times 1 is 3. 3 plus 1 is 4. So that means answer choice D is correct. This is all for the medium difficulty level. Let's move to our advanced difficulty level. Okay, on to our advanced difficulty level. This first question, all we're going to do is combine like terms to start off. So we have 4m squared minus m squared. That's 3m squared. Then we have 7m plus 3m. That's plus 10m. And then we have 5 minus 13, which is negative 8. Now we're going to factor this expression. We can factor this expression using the AC method. So 3 times negative 8 is negative 24. The factors of negative 24 that add up to 10 are negative 2 and positive 12. So now we're going to replace 10m with minus 2m plus 12m. So 3m squared minus 2m plus 12m minus 8. Now I can separate this into two different parentheses and factor each of them. We can factor out m from the first parentheses. We are left with 3m minus 2. And we can factor out 4 from the second parentheses. We are left with plus 4 parentheses 3m minus 2. Cross out this duplicate factor. We are left with m plus 4 as our first factor, 3m minus 2, which matches answer choice C. On to this next question. We have this formula for a circle, and we are trying to isolate the y variable. First step here, we can subtract x minus h squared on both sides, so we're left with y minus k squared equals r squared minus x minus h squared. Next up, we can go ahead and square root everything. So then we have this under a massive square root. Square root cancels out this squared term. So now we have, and remember when we take the square root of a variable, we have plus or minus solutions. So we have y minus k equals plus or minus the square root of r squared minus parentheses x minus h squared. And now to isolate the y, we're going to add k onto this. You might see that this only matches answer choice C because that k is going to be outside of that radical sign. So answer choice C is correct with this one. Okay, we have another circle. Circle is graphed. Which of the following represents the solutions? And the linear equation x minus y equals 3. We have standard form. Let's just convert that into y equals mx plus b format. So we have negative y equals negative x plus 3. And then when we isolate the y, we are left with y equals x minus 3. Let's go ahead and graph this. X minus 3. And then slope of 1 throughout that. So our line looks like this right here. So our linear equation looks like this right here. And now we're going to find the two solutions, which is negative 4 comma negative 7 and 3 comma 0, which matches answer choice D right here. So that is correct. Okay, to solve this one, we first need to factor it. So we're going to start onto this first question here. So if 2 to the power of m equals x and 7 to the power of n equals y, which of the following is equivalent to 784 to the power of m times n? So our first step here, we're going to separate 784 to the power of mn into two different factors, each with their that can be rewritten in this 2 to the power of 7 to the power of format. You might notice, well, if you didn't, then just go ahead and multiply, divide 784 by some perfect squares related to 2 and 7, meaning like 4 and like 49, things like that. So we can take 784 mn and rewrite this as 16 times 49 to the power of mn. Alright, now at this stage we can go ahead and separate this into our two different terms, 16 to the power of mn and times 49 to the power of mn. And now we can go ahead and rewrite these as like 2 to the power of something, 7 to the power of something. We'll start with 49. We know that 7 to the power of 2 is just 49, so we can replace 49 with 7 to the power of 2 to the power of mn. And now we can replace 16 to the power of mn with 2 to the power of 4 to the power of mn. At this point, we just need to know that well, at this point, we're just going to rearrange. We're going to move our 4 up, and our 2 up, and then our m down, and then our n down. We can do this. So this rearranges as 2 to the power of 4n up here, and then an m over here, and 7 to the power of n to the power of 2m. Once we rearrange this, we can now see that we have 2 to the power of m and 7 to the power of n, which we know is x for the first one, x to the power of 4n, and we know that 7 to the power of n is y. So now we have times y to the power of 2m, and this is where you may notice this matches the same format as answer choice D. So answer choice D is correct for this one. This is by far one of the hardest questions you'll probably see, maybe the hardest question on the SAT. However, we need to have a mastery of these properties of exponents in order to solve questions like this. We need to be thinking outside of the box in terms of these perfect squares in order to solve these questions. But if you have any specific questions about this one, make sure to leave it in the comments. So answer choice D is correct here. Let's move on. On to our next question. We have here, if 2x over 3x plus 5 equals 4, what is the value of x? We're just going to solve for x here. First step, multiply both sides by 3x plus 5. So we have 2x equals, after distributing that out, 12x plus 20. Now we can just subtract 2x on both sides. We have 10x, and then subtract 20 on both sides. We have negative 20. So we have negative 20 equals 10x. We divide both sides by 10. And we are left with x equals negative 2. If you ever wanted to double check these, we could substitute negative 2 back in for x. We are left with negative 4 over negative 6 plus 5, which is negative 1. And then negative 4 divided by negative 1 is positive 4. So it does work in this case. On to this next question. Which expression is equivalent to the sum for p is greater than 7? So whenever we have fractions, in order to actually sum them together, we need to have a common denominator. So we just need to think, what is the least common denominator between 3p to the third and 4p to the first? If you might notice, we can treat this as two separate things, 3 and 4, and p to the third and p. So p to the third and p, the least common denominator of that is p to the third, so we would need to multiply this by p to the second in order to reach there. But out of 3 and 4, p to the second over p to the second. But out of 3 and 4, the least common denominator of that is 12, which means we would multiply this first fraction by 4 in order to get to 12, and the second one by 3 in order to get to 12. So our least common denominator in full is 12p squared, but let's go ahead and do these multiplications in order to figure this out. So first of all, 3.5 times 4 is 14 over 12p to the third. And then we are adding this with 12p to the third in our denominator here. And then in our numerator, we have 21p squared. And now remember, when we add, we keep the denominators the same as 12p to the third, and then we add our numerators. Here, there is no negatives. So this is going to be equivalent to answer choice B right here, and we can stop right there. On to this next one, polynomial function g is defined as this, where a is a constant. If x plus 4 is a factor, then what is the value of a? So if you know that x plus 4 is a factor of the polynomial, that means when x equals negative 4, g of x equals 0. So we can actually use this to find a. So then 0 equals negative 64 minus a times 16. So minus 16a plus 68 plus 12. Now we can just solve this for a. 68 plus 12 is 80. Negative 64 plus 80. Negative 64 plus 80 is 16. So now we are left with 16 minus 16, a equals 0. If you don't notice right now, you can see that if a equals 1, then that does indeed equal 0. So the value of a is just 1. On to this next question. What are the solutions to this equation? We need to go ahead and actually rewrite this as one single quadratic function, which our first step is by writing it all on one side and getting rid of these parentheses. So 2 minus x squared. To get rid of that, we need to FOIL it out. So we rewrite it again. 2 minus x. So once we FOIL it, we're left with 4 minus 4x, and then x squared out here. So x, so this is actually x squared minus 4x plus 4. And then we can just move over the x minus 1 by subtracting x. So that's x squared minus 5x. And then adding 1. So x squared minus 5x plus 5. At this stage, we need to go ahead and use quadratic formula in order to solve for the solutions here. So let's go ahead and do that. Now, quadratic formula, we should have this memorized. I don't believe it's on our SAT reference sheet. Negative b plus or minus the square root of b squared minus 4ac over 2a. So you can see here that a equals 1, b equals negative 5, and c equals 5. So once we fill this in, we have 5 plus or minus the square root of 25 minus 4 times 5, which is minus 20. So we are left with 5 inside of that radical over 2. Then we can see here plus or minus. That means we have a negative solution and well, that means we can subtract the radical of 5 and we can add the radical of 5, meaning that answer choice B is correct for this scenario. On to this next question, all we have to do is FOIL this out. So 2 times 5d is 10d. 2 times 1/3 d squared is plus 2/3 d squared. 1/3 d times 5d is plus 5/3 d squared. And then 1/3 d times 1/3 d squared is plus 1/9 d to the third. Once we combine this d to the third and d to the fifth, we are left with 7 over 3d squared, 1/3 d to the third, and then 10d. That means that answer choice D is correct. Drake and Cleo are looking for a location to open a new yoga studio. A fellow studio owner suggests a location that will fit 28 students in a 756 square foot area, assuming each student has a spot x feet wide and 3 times as long. So what is the length in feet of space they are allotting to each student? So if there are 28 students in a 756 square foot area, that means that each student has 27 square feet to themselves. So, and that means that this 27 is going to be equal to x times 3x, well, which is an area is equal to length, well, the width times the length, which is 3x. So that means that 27 equals 3x squared. But now we can just solve for x, which we divide 3 on both sides. We are left with 9 equals x squared, and then we square root both sides, which means x equals 3. So x equals 3. Now we need to find the length. Do not select 3 here, because 3 is x. Our length, if you remember, 3 times as long is 3 times x, which is just equal to 9. So the length in space that they are allotting to each student is 9 feet here. Okay, on to this next question. The function is defined, which is the graph of y, negative f of x in the xy plane. You could know the transformations of an exponential function, but the easiest way to do this is just put this into Desmos. So first we have y equals 3 over 5 parentheses x to the power of x minus 1. So this is our original function. And let's replace this y with f of x, actually. And now we can see that g of x or the function that we're actually looking for here, is equal, actually no, y equals negative f of x. We can see that y is being graphed here. We can see clearly that this red graph is comes from negative infinity, and then we cross the y-axis at 0, 0, and then we have an asymptote at positive 1. The only graph that matches that is answer choice A. So answer choice A is correct here. Okay, on to this next one. The graphs are shown. Which of the following is the composite function of these two? So we can solve y equals j of k of x by just taking some values and substituting in. For example, let's take x equals positive 2 and find the y value of this new graph. So if x equals positive 2, we'd take k of positive 2. K of positive 2 is negative 3. Then we would take j of negative 3. J of negative 3 is then positive 3. So that means this new graph is 2, 3. We need to find which of these ones have 2, 3 as a coordinate pair. B has that, and D has that. Where B and D differ is after this positive 2 occurs. So let's go ahead and take the value for x equals 4. So if x equals 4, then we take k of 4. K of 4 is negative 5. Then we take j of negative 5. J of negative 5 is positive 5. So then when x equals 4, y is positive 5. So when x equals 4, y is positive 5. That matches answer choice B, and it does not match answer choice D. So with these composite functions, just take them slowly, use coordinate pairs in order to determine the correct answer. Okay, now on to this last question. G of x is a transformation of f of x. It shows f of x as a solid line and g of x as a dashed line. So we're going from this solid line to our dashed line. What is g of x in terms of f of x? Like transformation notation, the best way to do this is actually to model this. So let's say in our Desmos calculator that f of x equals negative 2x squared plus 4x and then plus 2. Okay, let's say that this is f of x. It looks pretty similar. So, and then our g of x, let's say that g of x, let's attempt all of these transformations. It should look similar to our dashed line. So g of x equals, our first one is negative 2 f of x. We can see here that does not look like it at all, so that's not going to be correct. Another one of them is 2 parentheses f of x. That looks to be pretty correct. We go above our function, and we seem to be narrower, which is the two key characteristics we're looking for. And then g of 1/2 of f of x we then write below, and then we are below f of x. Well, notice g of x is that dashed line, needs to be above and narrower, which is shown by this 2 f of x function. We are above and narrower than the original f of x. So that means that B is correct. We can see here that our vertex goes from 3, 2 to 3, 4. That is a multiplication of 2 from f of x, that solid line, to g of x as our dashed line. And you can see it's getting narrower. So that means that B is the correct answer for this one. Okay, this was it for this SAT math review video. I hope that you enjoyed. 39 questions that we all got done. If you have any further questions or comments or support with these super long videos, make sure to leave them in the comments and I'll make sure to answer them all. And I hope that you guys have a fantastic day and are doing well in your preparation for the SAT in March. Goodbye, everyone.